Welcome to our Group 7 presentation on enzymatic browning. Enzymatic browning occurs when the enzymes of fruits and vegetables are exposed to oxygen, for example, when we cut into an apple. Polyphenol oxidase oxidizes the polyphenols of the apple's flesh, then reacting with the amino acids and making brown-colored melanins, resulting in the brown-colored flesh we see on that exposed surface of the apple slice. This happens to lots of fruits and vegetables: bananas, eggplants, peaches, pears, lettuce, potatoes, to name a few. Some shellfish like shrimp, spiny lobster, and crab, and cereal grains like wheat and rice are also susceptible to enzymatic browning. There are two sides to every story, and enzymatic browning has both pros and cons. Cons include the browning affects nutritional qualities as well as sensory qualities like odor and flavor and decreases shelf life. The pros include some foods benefit from enzymatic browning's increase in color and flavor, like cocoa, tea, coffee, and dried fruits. Plus, melanin has antibacterial, antioxidant, and anti-cancer properties. In this week's demo, we saw various methods of preventing or slowing the enzymatic browning of a potato. Each of these methods slows or stops the enzymes from oxidizing. Sugar, saturated sucrose solution of table sugar and water, reduced the oxygen diffusion. The acid, which was a 5% acetic acid solution of distilled white vinegar, keeps the pH below 4.0 and inhibits PPO activity. The enzyme of papaya meat tenderizer serves to hydrolyze and inactivate the PPO. The blanching, quickly submerged in boiling water, thermally denatures the PPO. Other methods of inhibiting enzyme browning can include submerging the item in cold water, vacuum sealing, using fruit juice, chemical preservatives, sulfites, or cold storage. In this lab, each method was applied to a potato, which was then pulverized in a food processor, pushed through a strainer, and measured into a cylinder and visually examined for color comparison.
So, expectations. In order to test the prevention of enzymatic browning in this week's lab, Dr. H used a potato because, like apples and bananas and avocados, they're known to brown upon exposure to the air. Because as mentioned earlier in this PowerPoint, the oxidation reaction creates the brown melanin and brown pigment. So all methods used in this lab were actually expected to prevent the amount of browning because the control sample, as you can see in the photo, was still submerged or mixed with water, which could have affected the speed and amount of browning. And this is due to the lack of oxygen circulation, which makes it difficult for the oxygen to reach the enzyme. And this is something that many of us have experienced in our own kitchens, and that's why removing the skin of a fruit or vegetable can trigger rapid enzymatic browning compared to before you peel it. Now, expected results. So as mentioned, all samples included some ingredient that would slow enzymatic browning, even if it was just water. The control we predict would be the least or have the least impact on slowing enzymatic browning, just because there's no other ingredient aside from water added to the processed potato. So we're going to go over this table. So next, with the sugar sample, we expect some reduction of browning because in addition to the water, it has the added presence of sugar. And as I mentioned earlier, that can reduce the flow of oxygen and stop the oxygen from getting to the PPO, which would then, therefore prevent the reaction that causes the browning. With both the acid and the enzyme samples, we expect a large reduction of browning. For the acid, we would say, so PPO, which is made of enzymes, basically stop working properly when they're not in their ideal pH range. And in this case, the acid would lower the pH. And this is actually why a lot of people recommend squeezing lemon juice onto avocados to prevent it from becoming brown too quickly. In the case of the enzyme present in the meat tenderizer can prevent the enzymatic reaction of the PPO from occurring, and this would basically depend on the type of enzyme. It can work in a number of ways. For example, some enzymes compete with the oxygen. Sometimes they compete directly with the phenols. So that really depends, but either way, this leads us to expect a pretty large reduction of browning. And finally, blanching. We also expect some reduction of browning, definitely more than the control because the temperature was raised, even though it doesn't actually have another ingredient. And the reason is because the boiling temperature could cause denaturing of the PPO. The reason that I put some reduction and not large is because in this particular lab, Dr. H blanched it for just 1 minute, while most recipes and things online call for at least 4 to 5 minutes of boiling the fruit or vegetable to prevent the browning. Evaluations. So the method of evaluation for this lab was to examine the degree of browning that's observed in each solution. Ideally, this browning would be evaluated using a spectrophotometer to achieve accurate and objective results in data. This is because a spectrophotometer could separate the light, meaning the color, into its component wavelengths, and that data could then be digitized into numerical results. Unfortunately, without a spectrophotometer, the results can only be observed visually, basically comparing the different solutions to one another side by side, which would be basically looking at it and saying, this one is darker than this one. And we're going to see a comparison of the actual results in the next section.
Now on to our results from the demonstration. Taking a look at a picture from the demonstration, from left to right, we have our control substance, which had a fair reduction of browning with a cloudy yellow color. The sugar substance had a significant reduction, but it had a pale cream color, which showed just a little bit of browning. The acid solution had a very significant reduction of browning. It had the most, with its off-white color showing little to no browning. The enzyme solution showed a little bit of reduction, but it was a cloudy pale orange, almost pink color. And so did the blanching. It was very similar, almost the same as the enzyme solution. So our expected results were close to accurate. Our control, acid, and blanching expectations were met. However, our enzyme and sugar expectations were not. To answer how our principles can be used in the industry, we're going to discuss with avocados. So in the industry, it is important to keep food fresh to avoid wasting money and tarnishing the quality. So when working with temperamental ingredients such as an avocado, which tends to brown very quickly, chefs will slow the oxidation process. They'll do this by adding an acidic variable, which we saw based off the results that it does some pretty significant reducing of browning. They'll add one that won't harm the flavor, such as a lime or juice from a lemon. They'll also keep their items refrigerated as long as possible to help slow the process.